Good afternoon, and welcome back to Electronics Lab. We are going to move on in this lab to digital electronics. We've been doing analog electronics, and the second half of the semester, or the second half of the course, is about digital electronics, and then we do final projects where you can do either. So the first three labs were analog, and the second three labs are digital. So we got to, of course, understand what is the difference between analog and digital, and why do we care. So let's just get started. So, an analog signal. What we've been dealing with so far are analog signals. An analog signal, I'm going to leave what's on the screen for a second, but an analog signal, let's just say we are dealing with a sine wave, or something more complicated than the sine wave. But anyway, so some kind of signal. This analog signal requires that the thing that's reading it, or the receiver, right, when we graph this on an oscilloscope, it's got to be able to measure voltages, if this is voltage versus time, any voltage, right? So let's say that it's a 15-volt signal. It's got to be able to distinguish between 15 volts and 14 volts and 13 volts and minus 15 volts and 13.2 volts, etc. It's a continuously varying and continuously measured. It's a continuously varying signal, whereas a digital signal is a discrete signal. It doesn't have a continuum. All it is on or off. So a digital signal would be the example of what's shown above. It's either high, on, or low, off. And the point of a digital versus an analog signal is that a digital signal is a signal that is easier for one of the points is that it's a signal that's easier for some kind of instrument to read. For the analog signal, which we see at the bottom of the page, right? So a instrument needs to be able to read voltages at all these levels, whereas for a digital signal, all the system needs to read is it needs to be able to tell the difference between a high and a low voltage. It does not need to tell the difference between 15 volts and 14.9 volts. All it needs to tell the difference between is the high and the low. What is the high and the low? Well, the high could be 15 volts and the low could be 0 volts. So all it has to do is be able to tell the difference between 15 and 0. That's a digital signal. Now, more often than not, this isn't 15, but this is 5 volts. And I don't know why I'm writing an ugly olive color, but that's okay. So whether it's 15 volts or 5 volts, a digital signal, it just needs to tell the difference between high and low. Now, you might look at this and say, okay, but I can put a lot more information into the analog signal, into the bottom signal, right, than I can in the digital signal. Because the analog signal can vary, and so I can send a lot more information. And that is true that it takes more, to some extent, it takes a little more to send a digital signal, because what we do for a digital signal is we will encode the analog as digital. So we got to take an analog signal and we've got to encode it somehow. And so what I want to talk about first today is really a little bit about encoding analog to digital signals. But the concept of encoding an analog to a digital signal is not too different from the concept of a number being represented in base 10 versus base 2. I don't know if you remember that from third grade when you did your different bases. I actually don't know if you ever did them in school or not. But base 10, we have 10 different numbers, and we've got to be able to tell the difference between 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In base 2, we've actually only got two different numbers. You've got 0 and 1. And all you need to do is tell the difference between 0 and 1. And if you know anything about encoding numbers in different bases, that you can take any number in base 10 and turn it into a number in base 2. We'll talk about that when we get to it. So why digital signals over analog signals? Number one, digital signals, all we have to do is be able to distinguish between on and off, high or low, 5 volts or 0 volts. Right, I didn't write the words on and off here. High is the same as on, low is the same as off. 5 volts or 0 volts, or whatever high voltage we call it. In most cases, we're going to be dealing with 5 volts as our high voltage and 0 volts as our low voltage. So before I move on and get a little bit neater on the whiteboard, let's just think about what was the purpose of digital signals. Well, one is that it's easier for a device, any kind of device, but a computer maybe in particular, to read a digital signal without making an error, because all it has to do is distinguish between on and off. But also, digital circuits are typically used for basic operations in a computer. Digital signals are typically used, as you probably know. Logic operations in a computer are much more easily done on a digital signal than on an analog. Actually, it's very, very difficult to have a computer do logical operations on an analog signal, or even on a signal that's even if it's discrete, if it's got multiple components like a base 10 instead of a base 2. So we will see how we do logical operations in a computer, the building blocks of a computer, using a digital signal. So let's move on to a new page. So here I just show a number of ways to represent a digital signal. We can think of it as a light switch being on or off. Digitally, that's represented by the numbers 0 and 1. 0 means off, 1 means on. We might think of it as a low or a high, a low signal or a high signal. I make those two letters, but it can be LOW and HIGH. Or false is in when we're talking about digital signals, a 0 is the same as false and a 1 is the same as true. Stop, go. With a voltage it's often represented as 0 volts or 5 volts. But also when we're in circuits, especially when we deal with a certain kind of circuit called a TTL circuit, transistor logic, that ground, which it would be a 0 volts, is our off or our 0, and just an open circuit, infinite resistance represents instead of a 0 resistance to ground, infinite resistance, an open circuit represents on or high. So that's super useful because then we don't need a power supply, right? If in our circuit 5 volts is our 1, if a 1 in a digital signal meant 5 volts, then we'd have to put 5 volts as the input. Instead, what we can do in a transistor logic, TTL, it's called TTL, transistor logic, we can just have an open circuit instead of attaching a 5 volt power supply. The chip itself, the circuit itself, will be powered because it's still got to send a signal, right, to something in order to make some operation happen. But the high or the on or the 1 is represented by an open circuit. You'll see when we get there. Okay.